So this is going to be on our text?
Yeah, absolutely. You're going to start using these. You're going to have to use these if you want to find yourself to be successful in this class. You're going to have to know these inside and out. You're going to have to know your elements inside and out. You're going to have to know these naming rules. Now, with these, I'm trying to make your memorization shorter for you. Use what I use constantly in these things. Alright, so to start off, I'm going to use these four colors. Alright, so we're going to talk about these polyatomics, but the first thing you got to know with these polyatomics that you're going to deal with is there is a pattern. If you can get the pattern, then you'll be fine. And the pattern all comes from the root. So this block right here, you're just dealing with root ions. And this is the one we would label as most common. Now in terms for you don't need to worry about it. But with this root ion, you're going to build everything out from it. We're going to add some prefixes. We're going to change the ending of them. We're just going to do different things with it. So in this case, every one of these are involving the root. And I'm going to put the root in parentheses. Nah, I'll just do different colors. Every one of them have the root involved in it. That's why we can base this off of that. Alright? And so you're going to have things that's going to change around for you. So you're going to deal with different little doodads and hickman-doogers, as I'm going to call them. So, starting off. Let's do it. Alright, so starting off, let's say, let's go on and fill in the root. Let's finish the root. So in this, you're going to name this thing in a specific way. It's going to be the root and 8. So you got root and then 8 at the end. Let's do that black. It'll look better on the video. So root and 8. So I'm going to use for an example of this. Okay, so I'm going to pick one off of your polyatomic sheet. And I'm going to pick chlorate. So the root is chlor and 8 is the ending. And if you look off your sheet, it's giving the formula ClO3 minus. It has a -1 charge. You must memorize those charges. I'm going to tell you right now, if you don't get these charges memorized, it is going to hurt bad. Moving out from this, from the root, it's all based off adding or taking away oxygens. It's that simple. So this top one, let's say you have one more oxygen than the root. Then things are going to change now. You're still going to have the same ending on it. Alright, so you're still going to have the ATE. But the prefix, there's a prefix that gets added here. Per. P-E-R. Just follow the pattern. This pattern's here for you. Per. The root. Follow the root, which is chlor. And then the ending, 8. Perchlorate. It's one more oxygen. And the simplest thing here for you, charge stays the same. Trying to make your life simple here. So if you remember with chlorate, it doesn't matter if it's perchlorate or if it's chlorate, it's got that -1 charge with it. Alright? Now things get a little bit different. So let's say we'll start taking some oxygens away. Let's say you have one less oxygen than the root. Now here's where things are going to change for you. Okay? The ending on this is going to change as well. The ending will change here, and that's what you're going to be looking at. You change the ending from 8 to 8. So from ATE to ITE. Follow the pattern. Go with the root, chlor. Endings ite. One less oxygen in the root. Here's the root. ClO. I normally have 3, so it's 2. Alright? Now, in this box here, you're going to keep the same ending. So you're going to keep the ite. But in this case, let's say you have 2 less oxygens. 2 less oxygens than the root. Then the difference is going to be you're going to put another prefix in here. But this prefix is hypo. So hyporudite. It looks really bad. So hyporudite. So in this case, follow the pattern. Hypo, the root's chlor, endings ite. And it's 2 less than the base, than the root, sorry. So ClO, we normally have 3 with the root, so take 2 away. Be a 1, negative. So ClO minus. And you follow this pattern for all of them. Every one of them. Just follow this pattern as you're going. Okay? Is there questions right here, right now? You got your polyatomic sheet handy? Alright, on your polyatomic sheet, find carbonate. You should find carbonate to be CO3 2 minus. And that's what I'm saying when I'm saying these. I'm going through, I'm giving you the atoms, I'm giving you those elements, CO3 2 negative. That pause is telling you I'm going to that charge. There we got it now. Make sure it's in the shot. So CO3 2 negative. What's the name? Carbonate. Turn your paper over. Don't look at the sheet. I'm known to do this, and I'll do this on purpose. You need to get this at the foundational level so whenever we start bonding it with things. Name this. CO4 2 minus. Don't look at the sheet. You can look at your paper, or I left this here on purpose. Look at this. Yes. Per carbon 8. You get it there. Alright, so on this one, name this one. Hypocarbonate. Now I got a question for you. Name this. I think you said it. Close. carbon monoxide. Because it's a covalent bond, we use covalent bonding rules, we use those prefixes. There's one here for the carbon, so it's carbon. So we don't use mono with the first one, but the second one has a 1 and we use it, so it's carbon monoxide. I have a question. What's the difference with that and this? What's the difference? How do you know to name this carbon monoxide, but then all of y'all knew to name this hypocarbonite? Do what? Too negative. The charge. The key is that these polyatomic ions are groups of covalently bonded atoms that act and have characteristics of ionic bonds. If it has a charge like this, you're looking at a polyatomic ion. If it has no charge, there's no charge there. You have questions about that? No question. PO4 3-. If you need to look at your polyatomic ion sheet, I'm cool with that. You just recently got it. Look at it. Find the name. Phosphate. Now, PO2 3-. Alright, I got two things here. Somebody saying hypophosphite, somebody saying phosphite.
I'm making a rookie mistake.
I think it's phosphate here is like 30 years.
How many of you say phosphite? You all nervous to raise your hand? Oh, there's some confidence. How many of you are saying hypophosphite?
That's already told me.
I think phosphate.
I'm gonna go for the first one. I'm sorry if I let you.
Okay, so but why not
Hypophosphite. Why? What's the base? Here's the base.
Yeah.
How many? There's 4. How many is here? 2. That's 2 fewer than the base. Hypophosphite. You don't go by, it has 1 oxygen, hypophosphite, 2 oxygen, it's no, you go by the fewer. You look compared to the base, to the root, okay? If you have questions, listen to me. Tomorrow when you come in here, we're going to start using these. We're going to start using these in bonding and start using them based in bonding.